Today we're going to be solving equations using matrices and their inverses. So if you have an equation that's in the form A times X equals B, where A, X, and B are matrices, we can solve for X by using the inverse of A. So what we would do first, it's like having the equation 2x equals 6. What would you do to solve 2x equals 6? You could divide by 2, or you could multiply both sides by the reciprocal, which is called the inverse of 2. So what we're going to do here is we're going to multiply both sides of this equation by the inverse of A. And then I can use the associative property, and I can group these two together. The inverse of A times A. Well, what is 1/2 times 2? That's 1. That's the identity. So the inverse of A times A gives you the identity. It's like 1. So you got the identity matrix times X. Or it's like having 1 times a number. You get the same number back. So what we'll end up with is X is equal to the inverse of A times B. So this is how we're going to solve our equations today. So let's do some examples here. Solve each equation. Again, my variable is a matrix. So I want to figure out what matrix do I take times this matrix to get this matrix. So I want to know, what does X equal? So it's in the form A times X equals B. So what we're going to do to solve for X, we're going to multiply both sides by the inverse of A. The inverse of A and A cancels out. So X is equal to the inverse of A times B. All right, so this is A right here. We want to know, does A have an inverse? If it doesn't have an inverse, you can't solve this equation. So does A have an inverse? Well, we're going to see if it has an inverse. So we're going to calculate the determinant. The determinant of A will be 3 times -5 is -15 minus -4 times 4, which is -16. So what do we got? We have -15 minus -16 becomes -15 plus 16. So the determinant of A is 1. So this has an inverse. As long as the determinant is not 0, remember, it has an inverse. All right, so how do we find the inverse of A? Well, you put 1 over the determinant. So 1 over 1. It's always 1 over the determinant. And then you're going to multiply that. Well, the ones I have circled in green, remember we switched those. And then the ones I have circled in blue, we change the sign of those. So the inverse for this problem here will be 1 over 1, which is just 1. So this reduces down to 1. So I'm going to multiply all of these by 1. So if I multiply those all by 1, nothing happens. It stays the same. So this is my inverse. -5, -4, 4, 3. What do I do with the inverse? I multiply that by b. B, again, is this matrix right here. That's my B matrix. 0, 0, -22, -28. So I'm going to multiply that by the inverse of A. So I'm going to take the inverse of A, which we found here, multiply by this. So let's draw our dividing lines in. So I'm going to go row times column. So the first element in this row times the first element in that column. -5 times 0 is 0. Plus the second element times the second element, which is 0. So we get 0. Now I'm going to do this row here, but now I'm going to use this column. So -5 times -22 is going to be what? Positive 110. And then 4 times -28 is -112, which we get -2. Now we're gonna do the whole process over again. But this time we're using the bottom row. We're gonna use this bottom row and this column. -4 times 0 is 0. 3 times 0 is 0. 0 plus 0 is 0. Use the same row, but use this column here. -4 times -22 is going to be positive 88. And then 3 times 28, -28, is -84. So we get 4. So this is what x is equal to. X is equal to that matrix. Okay? So let's do one more example here. Let's do B now. So here's my B. I want to solve for x. So again, this is my A, this is my x, this is my B. To solve for x, we take the inverse of A, multiply by B. So we got to find the inverse of A. So we're going to find the determinant of A first. -8 times 2 is -16 minus 2 times 10, 20. So the determinant of A is -36. All right, let's find the inverse. The inverse is equal to 1 over the determinant. So 1 over -36. And then remember these two elements here, we switch those. And then these two elements, we change the signs of these. So the inverse of A. The inverse of A would be this matrix right here. -1 over 36 times 2 is -236. You can reduce them if you want, or you can just leave them separately. If I was asking you just find the inverse, I would always want you to reduce it. But because we're gonna be using the inverse to solve the problem, it's actually easier not to reduce these. So negative 136 over times negative 10, negative times negative will be positive, so 10 over 36. 1 over negative 36 times negative 2 is gonna be 2 over 36. 1 over negative 36 times negative 8 would be positive 8 over 36. And then remember, we'll multiply that by b. And b was 12 and negative 30. So if we draw dividing lines in here, we draw dividing lines there, but there's no dividing lines on the other one. Because what we're taking 2 by 2 times a 2 by 1. The 2 in the middle match, so our answer should be a 2 by 1. So the answer that we're gonna get, x, is gonna be a 2 by 1 matrix. So it's gonna have 2 rows and 1 column. So we're gonna take this row here times this column here. So the first element times the first element here. So negative 2 times 12 is negative 2436. Plus, second element times the second element. 10 times negative 30 is going to be negative, what, 300 over 36. So, negative 300 plus negative 24 is negative 3/24 over 36. Which is negative 9. Now let's do the bottom one. To do the bottom one, we're going to use the bottom row in that column. 2 over 36 times 12, where that's going to be 24/36. And then 8 over 36 times negative 30 is going to be negative 240 over 36. We got a common denominators, that's why I didn't reduce. So I can have common denominators, so I'm going to take negative 240 plus 24. It's negative 216. And negative 216 divided by 36 is negative 6. So x is equal to this matrix here, negative 9, negative 6. So here was our work for those 2 examples that we just worked out here. I'll leave it up here. You can pause it at this point. You can examine them some more.